Alright, hello everyone. So here we have an initial value problem to solve. Now what do I mean by an initial value problem? Because we have not only a differential equation, we have the initial condition, right? So this is an initial value problem. Well, let's focus on the differential equation and then later we can use the initial condition. Now we want to separate this. It's easy separation because 9x times e to the y, we can just take e to the y to the left by division and keep 9x on the right. That's easy, right? Okay, now we can integrate both sides. To help with our integration, let's write it as e to the negative y dy, and 9x, if you integrate 9x, you get 9x square over 2 plus constant of integration c1. Now if you integrate e to the negative y, you get e to the negative y divided by negative 1 because of this negative is equal to 9x square over 2 plus c1. Let's take this negative 1 to the right. So it's e to the negative y negative 9x square over 2 plus, well, this should have been c1. Let's call this c2 because c2 is negative c1. Okay. Alright, now to find the explicit solution for y, we can take the natural log of both sides, natural log e minus y, natural log, absolute value here, negative 9x square over 2 plus c2. Now someone might ask, why don't I have absolute value on the left? Well, e to the minus y is always positive. Exponential function values are always positive in this case. Okay, so doesn't matter. Alright, so we don't need to have the absolute values. So we can take the e. Oh no, I'm sorry, I was thinking something else. So we can use the logarithmic properties. We can bring negative y in front of natural log expression. So natural log e, negative y times natural log e, this is negative 9x square over 2 plus c2. Well, natural log e is 1, so that makes our explicit solution y is equal to minus natural log negative 9x square over 2 plus c2, right? So this is the explicit solution. Oh, we forgot, this is an initial value problem, right? The initial condition is y0, 0. So let's use that. When x is equal to 0, y is 0. So y is 0 when x is equal to 0. x0 means this term is completely 0, so natural log c2. Okay. Now negative doesn't matter, so what we have is natural log absolute value of c2 is 0. So if we take e, c2 is e to the 0, right, which is 1. So c2 is 1. That was nice. Now y is then the final solution is minus natural log absolute value of 9x square over 2 plus 1. Okay, all right. So this is the final solution. Perfect. Let's solve another problem, okay, in the same video. Let's solve the differential equation y prime is equal to 1 over xy plus y. Okay, what can we do about this differential equation? Well, first of all, y prime means dy over dx. Now, how can we separate the variables here? Looks a little bit complicated, right? Well, don't worry. Focus on the denominator on the right hand side. We can factor a y out and it's going to be y times x plus 1 on the denominator. Now how can we separate? Super easy. Take this y to the left, so it's y dy because it's in the denominator on the left. When you take it to the left, denominator on the right, when you take it to the left, it comes to the numerator, and it's going to be 1 over x plus 1 dx. Easier than you thought. Now we can integrate. If you integrate y, it's y square over 2. If you integrate 1 over x plus 1, it's natural log absolute value of x plus 1 plus constant of integration c1. Let's multiply the right hand side by 2. So it's 2 natural log absolute value x plus 1 plus 2 times c1. Let's call it c2, another arbitrary constant. Let's get a little bit fancy here. Let's write this as natural log x plus 1 square. You don't need to do that. It's not necessary, but I'm trying to get fancy and trying to show you some math. So places where you can use algebra, but it's not necessary. We can take this 2, we can write it as a power of x plus 1 using logarithmic rules here, okay? Perfect. Then the absolute value goes away because x plus 1 square is always, of course, positive, no matter what x value you have, right? Let's just take the square root. So it's going to be plus or minus square root of natural log x plus 1 square plus c2. That's the solution. Okay. All right, let me solve another problem in the same video, because we only use 5 minutes so far in this video. This is going to be the final problem. So y prime is 5xy minus 2x. Y prime is dy over dx. What can we do about the right hand side? Well, x is common, right? So let's factor x. So it's going to be 5y minus 2. Oh, integration is going to be interesting. Let me show you something that you might have forgotten. Now let's separate. We can take 5y minus 2 into the left and keep x on the right. Now here's where integration gets interesting. So integral of x is x square over 2. That's easy, and plus c1. What is the integral of 1 over 5y minus 2? Well, here the power of y is 1 and it's in the denominator. So it should be natural log absolute value 5y minus 2, right? Now I would say one thing is missing. What's missing? What do you think? Well, if you remember basic integration, here we have 5, coefficient for y, so you have to divide by 5. Okay, so if you have forgotten, you should go back to basic integration review video series and recall them, okay? Alright, so let me quickly recall it. So if you have to integrate 1 over ax plus b, something like this, the solution is natural log absolute value ax plus b divide by a. So that's a rule, okay, that you should know. This is not 9, this is a. Okay. Anyway, now to find the explicit solution, so let's take that 5 to the right. Natural log absolute value 5 minus 2. 5x square over 2 plus 5c1, let's call it c2, okay, 5c1, c2. Now let's take the e of the right hand side, so 5y minus 2 is e to the 5x square over 2 plus c2. We can break the plus here as 5x square over 2 e to the c2. So let's write e to the c2 as c, okay, so e to the c2 as c. So c e to the 5x square over 2 helps us with the algebra. It's always nice to do those things. So 5y, let's take minus 2 to the right. So c e to the 5x square over 2 plus 2, and let's divide by 5. So c over 5 e to the 5x square over 2 plus 2 over 5. That's the solution. So here's something where you can become fancy. So c over 5. Still, it's an arbitrary constant, right? So let's write it as c3. c3 e to the 5x square over 2 plus 2 over 5. So that's the explicit solution. Okay, so c3 is c over 5. There's so many things you can do. You could have written this solution here from this step as y is equal to c e to the 5x square over 2 plus 2 divided by 5, the whole thing divided by 5. That's also correct. This is just, I'm being fancy with algebra and I'm using the strength of algebra in these math problems, okay? It's always nice to do those things. Alright, so that's it. That's it for separation of variable video series. So thank you very much. Bye-bye.